You might have maybe only 100 patients for some kind of rare cancer, but you might measure for every single one of them maybe tens of thousands of genes. And the suspicion is that out of those 10,000 genes, maybe 20 to 30 might be relevant. The catch is though that you don't know which ones. So if you would know which ones they are relevant, then typically predicting whether or not someone has cancer is relatively easy. But if you don't know that, then you have to kind of find out of this enormous haystack somehow the needle of those 30 that actually matter. And this is something that actually computers can actually figure out relatively fast. Although that there are kind of almost more possibilities than there are probably atoms in the universe, selecting out of 10,000 genes, 30 that are relevant. Computers can kind of do that relatively fast. Okay, there are some methods that are being developed for that kind of can do that without explicitly enumerating all possibilities. And those actually work very, very fast, actually much faster than what people thought how fast they could work. It's something that one of my own research contributions is kind of to convince people that these type of methods are not as slow as what people previously thought, perhaps. It's a combination of computers getting faster, so just Moore's law, but also these types of methods that do this type of selecting those 30 out of a huge number of potential ones. They also became kind of over time much faster as well. So there's like a double exponential improvement in how fast we can solve these problems, simply because computers get fast, but also the software that kind of does that became faster as well. So maybe 20 years ago it would be true that this problem cannot be solved. There's just too many combinations. Nowadays you can actually solve such problems rather quickly on modern hardware with modern kind of algorithms. So that's something that is something to watch for the future. Many of these problems that now are kind of we don't really know how to solve, simply by these improvements, we hope that we can kind of push the boundary of what types of problems we actually can solve. These type of problems are so difficult that you do actually care about how fast they are. Of course, in some applications, I always say that speed is somehow is relative to what you want to solve. So there are some applications in which you need to make decisions. For example, I talked about control, where you need your decision within a few seconds. You want to decide what to do almost online, like while you're doing it. You cannot afford to wait very long. But for example, for these cancer prediction types of problems, well, if the algorithm takes maybe like a week to solve, well, that's still okay in some sense, because you try to find the genes that are relevant. It's something you can do once and then you're done. You don't actually have to do it over and over, so you can kind of spend some time. But the speed of the algorithm is relevant in the sense that because these problems are so difficult, just by computers getting faster, it's not enough that they eventually will be able to solve quickly. We also need this, the algorithms need to be kind of improved as well.